Section 6.6, division of polynomials. We're going to take a look at dividing by a polynomial when the divisor has more than one term, as it does here. We're dividing this polynomial by y plus 1. We use a procedure very similar to long division in arithmetic. A couple tips for dividing polynomials is arrange the polynomials in descending order, and if there are missing terms in the dividend, this is the dividend, either write them with a zero coefficient or leave spaces for them. And we are missing some powers in this problem. We have y to the fourth, we don't have a y to the third, we have a y to the second, we don't have a y to the first power. So using a procedure very similar to long division, but keeping in mind either leaving a space or putting that power with a zero. 0 times y to the third is still 0, so I haven't changed anything there. But cosmetically I've altered it, and you'll see in a minute why it's important that we leave a space or put a 0 in there. The next decreasing power is y to the second. So we mentioned there isn't a y to the first, so I'll put 0 times y, which is 0, and then add the constant term of 2. To do our division, we go to our highest power of our divisor and determine what we need to multiply it by to get this leading term here. We clearly needed 3, and to bring y up to y to the fourth, we need a y to the third power. Distributively then, 3y to the third times y is 3y to the fourth, but we also need to multiply it by this second term. 1 times 3y to the third is positive 3y to the third. Now if we hadn't left a space, we would have had our y to the third underneath a y to the second. In division, just like in arithmetic, we subtract, but to make sure we don't lose a sign or make an error on our subtraction, use the rule of subtraction, which is a minus b is the same as a plus the opposite. So I'm subtracting this quantity, and I might remember 3y to the fourth minus 3y to the fourth, but I might forget that I'm also subtracting this second term. So the best method is to use your rule of subtraction, which says take the opposite. I have a plus here, so I'll put a minus as well as this first one, and change it into addition. 3y to the fourth plus a minus 3y to the fourth cancel out. You do want that leading term to cancel out. Simplifying further, 0 plus a negative 3 is a negative 3y to the third. And just like in long division, in arithmetic, we bring down the next term. We go back to our divisor. What times y gives you negative 3y to the third? Well, we'll need a coefficient or a multiple of negative 3. And to get our y to the third power, we will have to have a y to the second power. Negative 3y squared times y, we're distributing that, gives us a negative 3y to the second. Negative 3y to the second times 1, distributively, timesing each of our divisor by this multiple up here, gives us a negative 3y to the second. We're subtracting. Subtraction is the same as adding the opposite. We have a negative, so we'll turn it into a positive. We have a negative, so we turn it into a positive. We have changed the signs to the opposite, and we're ready to add. Negative 3y to the third, this should be to the third. I didn't say that right when I multiplied it here. We had y to the second times y is y to the third. My bad. Adding these together cancels out, that's the goal. 1y squared plus 3y squared gives us 4y squared, and we're ready to bring down the next term. Going to the top again with our divisor, y times what gives you 4y to the second? Well, we need a positive 4, and to get to the square, or the power of 2, we will need another y. 4y times y is 4y to the second. 4y times 1 distributively across all the terms in your divisor gives us a 4y. And again, without that placeholder, we wouldn't have had the right term lined up here. We are now ready to subtract, but we're not going to subtract this whole quantity. Instead, we're going to change the sign to the opposite. So our 4y squared becomes a negative, our plus 4y becomes a negative, and then add. 4y squared plus negative 4y squared are gone. That's the whole idea. And 0y plus a negative 4y is a negative 4y. We're ready to bring down our last term and go back to the top. Y times what gives us negative 4y? We have the y, but we need a negative 4. We'll take negative 4 times y, which gives us a negative 4y, and we can't forget, we also need to multiply it by the 1. 1 times negative 4 is negative 4. Subtract this whole quantity. Instead, using the rule of subtraction, we'll change the signs to the opposite and then add, because of the rule of subtraction. The y terms are gone. 2 plus 4 is 6 for our remainder. So we would write, this is our quotient, 3y to the third minus 3y to the second plus 4y minus 4, plus our remainder of 6 over y plus 1. To check this problem, we would take our quotient, this 4-term polynomial, multiply it by our divisor. Remember, to check a division, we multiply, and then add that remainder on. Should bring us back to this polynomial that we started out with.